So tomorrow you're going to take part 1 of your post-test, and on the review packet it goes from number 1 to number 14. Now, for our classes, we already started this review last week, so we're going to kind of like halfway do these. I think we got to number 9 or 10, depending on which class you're from. So we're going to maybe do some alternative problems that are highly associated with the problems that are already on the review, and maybe write down a few formulas. So yes, you do get a formula sheet. Someone remind me of the formula that you're going to use when it comes to finding the arc length. This is your formula sheet, by the way. Which one helps you with arc length? Yeah, that very first one. This guy is arc length. So r times theta, but the reason that formula is so pretty to look at is because theta must be measured in radians, and it says right on your formula sheet, it must be in radian measure. So this question, guys, we already worked through it, but the radius is 11, and then your angle is 80 degrees, but what would you have to sneak here to convert it to radians? This you do have to have memorized. Yep, you'd have to multiply it by pi over 180, and we discussed that it needs to be rounded to the nearest tenth, so they don't want in terms of pi answer. However, I will accept it. Similar problem? There's not really much I can do to that one. Do you guys need a secondary problem on that? I can make one up real fast, but it'll be the same thing. Okay. All right, so this next one is the one that you guys probably struggled with the most on the last time we tested it, which was a long time ago, like January, February, maybe, after all the snow days. The linear velocity formula that I would like you guys to focus on is this one. However, before you get to that formula, you need to talk about how to find angular velocity, which has to be in radians per time value. So if they give you an angular rotation thing and it's not measured in radians, that's the thing you have to start converting. So like, for instance, right here, 4,000 RPMs is kind of like theta. That means rotations per minute or revolutions per minute. So how would I convert that to radians? Off of rotations. One rotation is 2 pi radians, right? And it doesn't, if I look through the question, it doesn't say anything like change centimeters to meters. It doesn't change time value at all. So you guys don't have to do any secondary conversions. The important thing, though, is that when you go to label this question at the end, that you actually give it the right label. So for this part of the problem, I might call theta 8,000 pi because I'm still in the middle of my work, right? Now I have to go find linear velocity, which is r times theta. So here's the radius. So 5 centimeters times this 8,000 pi. And then whatever that came out to on my calculator, because I do want to get to the nearest tenth. What's your label on this? If it's linear velocity, yeah, it was measured in centimeters per, nope, it was minute, wasn't it? Minute, yeah. So if you took the time to convert something off of centimeters or minutes, that's fine. Just make sure you have the right label. But if it doesn't ask, I would say just don't do extra work. You good on that one? Do we want a secondary problem with that? Okay. Let's take a look at this guy. So this is the one where you're sketching, making sure you're in the right part of the coordinate plane. That it's going to kind of lead you through the question on the test. It's going to say you must sketch it. So negative 5, 12. Why is it so important that we sketch it? Because you have to watch your signs, right? Now the r, the hypotenuse, is always positive. You can do Pythagorean theorem or notice as a Pythagorean triple, but the 12 is going to be positive because it is. And then the cosecant formula, there is something on your formula sheet that discusses cosecant. I think it says it's like cosecant is 1 over sine or something like that. So if you for some reason panicked and you forgot what cosecant was, you can look that up. But I'm hoping you guys remember what cosecant means. It is the reciprocal of sine, so instead of 12 over 13, that would be 13 over 12. Always watch what quadrant you're in to make sure that your sign on your answer matches the sign that it should be. Because remember, this is graded traditionally. So if the answer was this, and you made a small mistake, it is wrong and you've lost your point. Okay? So it's not like, oh, how cute and adorable, you lost your sign. No, it's just going to be wrong, so be careful. This one is directly off the unit circle, so go find, and you will have a unit circle in front of you, go find 5 pi over 3. It's like down here, isn't it? Well, I didn't draw it very well. What's new? But what's the ordered pair down here at 5 pi over 3? Is it 1/2 comma negative square root of 3 over 2? Okay. So then I have to remember, okay, how do I find cotangent? So a few different formulas. Some of you think of it as the reciprocal of tangent. Some of you think of it as x over y. And some of you think of it as cosine over sine. And I think the cosine over sine formula is somewhat given to you on your formula sheet. So if you're always in a jam for formulas, go back to your formula sheet, okay? Cosine, what is cosine? 1/2. And then instead of dividing by sine, remember we always multiply by the reciprocal. The 2's cancel. Don't lose your negative here, guys. And then instead of negative 1 over square root of 3, I'm going to expect you to give me an exact rationalized answer. So hit top and bottom by square root of 3 over 3 is the final answer. Negative square root of 3 over 3 is the final answer. Do we want a secondary question of that? Now notice the one on the review is cotangent, because we know that's the one that gives us the most trouble, tangent and cotangent. So don't be surprised if the one on the test is tangent or cotangent because of that very reason. Okay? Unit circle, hi. All right, moving along. This is the one where they give you a weird random clue about what quadrant you're in. So again, it's going to walk you through it. So it says cosine is greater than 0, which means positive. And then sine is negative 7 over 25. So sine is negative. So I think about what quadrant I should be in. And remember, are all students take calculus mnemonic device? Which quadrant has a positive cosine but a negative sine? That'd be down here in quadrant 4. Roman numerals or numbers work for me. You can even write out the word 4. I don't care. Just make sure you're in the right quadrant. And then it does say to sketch. So sine being negative 7 over 25. Watch who's the negative one, though, because it's, remember, like the opposite leg over the hypotenuse. And then to find this missing leg, either reverse Pythagorean theorem where you have to subtract it, or maybe you recognize that the Pythagorean triple of 7, 24, 25. Is this leg negative, though? No, it's not. So make sure it stays positive. Make sure you know how to explain. Some kid on Friday said, well, I'm just going to draw. And I said, that's not explaining. Like, I expect a sentence or two. It doesn't have to be any great literary work, guys, but you should write words. And then finally you get to find the tangent. So tangent being negative 7 over 24, and then I think to myself, okay, I'm in the 4th quadrant. I just gave my teacher a negative tangent ratio. Yes, that makes sense. We're solving trig equations. There will be one on your first part of your post-test, and we're not trying to trick you guys. So like when I say this one is the kind of trig equation that you have to factor out something, what do you think will happen tomorrow? You're going to have a trig equation where you have to factor out something. So look for the common factor. What is the common factor that both of your terms have? Cosine. And if you, oops, theta, x, whatever. So if you take out a cosine, you still have 2 times a cosine. And then minus 1. And then now that you have your 2 factors, which this guy right here is a factor as well, you're going to set each of them equal to 0 and solve. So very basic factoring question for trig, but you do have to be careful about what you're doing. So where is the cosine 0? And then this one, you have to do a little algebra before you can look at your unit circle. So like right here, if you added the 1 and divided by 2, you're asking yourself, where is cosine 1/2? So start rattling off some places where let's start with cosine is 0. Remember, your ordered pairs on your unit circle go cosine comma sine. So who has a cosine of 0? What? Pi over 2. And 3 pi over 2. And then cosine of 1/2 would be pi over 3 and 5 pi over 3. And then it does say all solutions. So what are you supposed to do now? Yeah, the lazy kid, me, I'm talking about me, just does this. Oops, I don't know why I went out of order, but who cares? Oh my gosh. Dyslexia is strong today. And then I'm going to do this. Plus 2 pi n. Now, if this was my homework, I literally would have drawn a line down. This being your big show here at the end of the class, guys, could you do me a favor and like literally write plus 2 pi n? That'd be nice. You look like you're not going to do that. Maybe do it. It's your last chance to really impress me. Oh, that's not true. It's not even close to your last chance. Haha, joke's on you. All right, so far so good. Do you want to see another example of that? Okay. You got that face, you're good? Okay, so now we have to really focus in on, okay, I'm going to be given a very strange equation for graphing sine and cosine, and I got to be able to pull out the pertinent pieces, starting with b value. So b value is the coefficient to the variable or factored out of the phase shift. It's inside of your sine and cosine function. So when we look inside of our sine and cosine function, I notice this weird 3 pi over 5 number. That is the b value. Gross. And it's going to be gross on your test because you guys are not new to this. So now it says find the period. Well, how does one find the period? And this you do have to have memorized, I believe. I don't think it's anywhere in your formula sheet. So it's normally 2 pi for sine and cosine, but then you have to divide it by whatever the b value is. So then I got to say, self, how do I divide fractions? And the answer is I don't. I multiply by the reciprocal. And it looks a little gross, but it works out nicely because the pi's are going to cancel. And you end up with 10 over 3. So expect to see a funky b value and probably a funky period length too. So this next one. When you have an equation, and inside of your cosine or sine function, there seems to be some factorization. That is good news, because that means you should be able to identify the phase shift just by looking and not doing any work. Now, since the 3 is factored out, this guy here indicates the phase shift, and I need you to remember what it means. Anytime math has parentheses sets, that's transformational formula. So it's shifted pi over 6, but what direction? To the right. Very good. So just like everything in algebra, when it was in like transformational form in parentheses, there's always an opposite factor effect because there's a built-in negative there. I know what's on your formula sheet is kind of, I think it's a little misleading. Do they use the plus? Is it even on your formula sheet? I don't know if the graphing, can I steal that for a second? Thanks. Maybe it's not even on there, so don't worry about it. But definitely not the kind of question where you want to second guess yourself. I guess if you got to the end of day 1 testing and you were like really hemming and hawing over it, maybe you could try graphing on your calculator. What mode could you be in your should you be in your calculator if you're graphing this though? Yes. Remember, we've been doing some weird stuff lately with polars and everything, so some of us have learned that our coordinates are weird. Can y'all, if you have your own personal calculator, can you go to mode for a minute? Yes. Make sure you're in radian mode, and make sure nothing else is weird there. Function. And then go to format, which is second zoom, right? Yeah, second zoom. And at one point, you may have turned on your polar coordinates, because we needed those for polars. You don't want your polar coordinates on anymore, guys. You want rectangular coordinates on, your normal good old XY ordered pairs. Now, if you don't have any programs, you can just reset your calculator at the morning and just call it a day. But if you have programs, you don't want to lose them, don't reset your calculator. If you, I don't want you to test this out. I think if you do not the all RAM, if you just go back to defaults, it does all those settings back to normal. You're not testing it out. Anyone have like one program they don't care if they lose? Don't sacrifice your programs for me, people. Well, here, someone with a yellow calculator, because we don't care what happens with those. Change the modes and turn on some weird stuff, like turn on polar coordinates for a minute. And then, this is fun. This is fun. And then after you change some stuff, go to the memory. Anybody know where the memory is? This is the other way to reset your calculator. It's right above your, it is in your catalog, but it's above your plus sign is the easier way to get to it. So second plus sign. And then go to reset. It'll give you 2 options after this menu. You just panicked. You're like, don't do it. Instead of all RAM, choose defaults. And then let me know if it puts your modes back. Well, yeah, the regular way wipes all your memory out. So that one for sure. But I want to know if defaults puts the modes back. Oh, cool. Okay. So just, it won't delete your programs if you do defaults. Because all defaults does, it doesn't wipe your memory, but it sets all the factory settings back to normal. I know, you don't trust me. It's okay. You shouldn't trust me. It's okay. It's good to be paranoid. It's just a turtle. The internet doesn't get our jokes. Okay, moving on. Do you guys want me to quickly make up something weird? Don't. Okay. We got a taker. Okay, there we go. It's weird, as promised. Now, I can't promise you all these parentheses will be there. That's just like a personal preference for me. I like to add parentheses around like what's in the cosine function and everything. So it's possible that you guys will not see these parentheses right here on your test. Oops, the S will be there though. So it might look like that. So my first question might be, what is the B value? It is that weird 2 pi over 7. So what if I said, now go find the period? So what's the formula for finding period again? It's the normal 2 pi divided by this b. But we don't divide by that. We multiply by the reciprocal. Oh, it's not as weird as I thought. So that's kind of nice. The period comes out to 7. That's very strange. And then maybe a follow-up question might be, is there a phase shift? And your answer is yes. What is your phase shift? Pi over 2. What direction? To the left. Very good. Because the plus pi over 2, and because the b was factored out, the plus pi over 2 is really a opposite of that. Very good. All right, we did some sketching. It was a good time. Would you like me to make up another one, or just go through this one again? I mean, just go through this one again for our hand up and in. Okay. We have 4 cosine 2x. So that's a pretty nice basic function. The midline is at 0, so I need all the help I can get. I'm probably going to bust out the highlighters here. There we go. It's still going to be bad, but that's okay. All right, maximum line is located at where? It's 4 units up from the midline, so we'll pretend that's 4. Ooh, that's not straight. Ooh. And then this guy would be -4. Good enough. Now I need to sketch, which means I need to find the period, and then typically we find the quarter points next. I know some of you have different approaches. The one on the test will be like this. It's not real complicated, doesn't have a phase shift in it. But the fact that there's a 2 inside of the cosine function means the period has changed. So the amplitude you guys already told me was a 4. What if this was a negative value out in front? It's still the absolute value of that number, so if it said -4, the amplitude would still be a 4, but when I go to graph it, it is reflected. Very good. The period is 2 pi over this b value, so the period comes out to pi, which means between 0 and pi, you're going to see the full cosine wiggle. And it does say label ordered pairs, sketch at least 1 period, and then there's some go-getters out there who are like, I'm going to sketch all the periods. Cool for you. This is a timed test, so keep that in mind. I don't know if going above and beyond to impress your teacher, this is probably not the moment to do it. So talk to me about the fact that this is a cosine function. Where should this be starting? Up at the top, right? Now the period length, if you want to know where to mark all your quarter points, usually we have this little side moment here where I say, oh, go find your quarter points. So you take the period and you divide it by 4. So this one doesn't take, it's not a real thinker, is it? What's pi over 4? That's right, kids, it's pi over 4. If that reduced, I would expect you to reduce it. Whoops, that's 4. So count with pi over 4s with me, guys. 1 pi over 4. What's next? Yeah, you can write 2 pi over 4. It's fine, just reduce it later, but it is pi over 2. So then we have 3 pi over 4. And then again, if you wrote 4 pi over 4 just for the counting purpose, that's fine, but I would expect you to reduce it at some point. You should see some like graphing symmetry though. 0 starts up at the top here, 4, and then the next pi over 4, which must be in the middle here, comes back to the middle. Oh, pen. What you doing? There we go. And then next ordered pair is down here at the minimum, which is -4. Then back to the middle, back to the top. And then you hope for the best. Close enough. So that's all they asked for. They said 5 ordered pairs, label them on the side. Boom. I'm moving on. Because it's a timed test. And my teacher's a real stickler about that. Jerk. All right, moving on. Right? This, oh boy. Tricky, tricky, tricky. Not a cosine equation. You must create a sine equation. Now the fact that it's on your review this way tells me it's probably on your test this way as well. We're not trying to trick you. We would definitely never give you something like too easy on the review. If anything, we might err on the side of caution and give you an extra hard one on the review. But I think this one's just like the test. I think, because at first when I look at this graph, I'm like, ooh, that's a beautifully reflected cosine graph. Is that what you guys are thinking too? I was until I read the directions and it said, nope, sine. So, alrighty, if I have to choose a sine function to graph, that means we're going to have to incorporate a phase shift. It is up to you guys where you start the sine function, but what I might suggest you do is figure out where your maximum and minimum are. And remember, these graphs are sometimes kind of hard to read. So, especially down here in negative land, some of you like lose negative signs because of the way the graph looks. That is definitely a -4. And some of you are very good, most of you are very good at visualizing where the middle is, and I'm not one of those people. So I think it's here. Pretty sure it's there. But how do you find the middle if you're not sure? You just find the middle by adding them up and dividing by 2. So 2 plus -4 divided by 2 is -1. Now that middle line is very important over here. You want to just go ahead and write that down while we have it? Who here is that -1? That's your vertical shift. So you can say down 1. Some people say y equals -1 because they associate that with the midline. Absolutely fine. I don't care what you write down. The amplitude should be pretty obvious now that I'm looking at it. Ooh, that was supposed to be straight. The top to the middle, or the middle to the bottom. How big is that? 3. Should you ever be writing a negative number here for amplitude? No. Now the period, it doesn't really matter where you start and stop. You just need to figure out how long it takes for one complete cycle to go through. So if you want to pretend it was a cosine for a minute, start here and stop here. How long did it take? Pi. Yeah. So now what I need from you is to go backwards and find b. So the formula for finding b and the formula for finding period are actually the same proportion, just rearranged a little bit. So the b value is 2 pi divided by the period. So for us, that would be 2 pi over pi, so the b value is a 2. If you're looking for a double check, like I know some of you like to test and like triple and double check your work as you go along, the whole point of a b value, it's how many cycles it completes between 0 and 2 pi. So if you look between 0 and 2 pi, can you tell that there have been 2 complete cycles of that wave? That's what b means. So that's what I really need from you is the b value, because you're about to write an equation for me. Except, we're going to have to use a phase shift. Tell me why. Because they said you have to have a sine function. So I don't know about y'all, but I'm feeling like this is a splendid start spot. Can you tell where that is? Because it's not all the way over to pi over 2. It's halfway, so this must be pi over 4. So I'm going to say phase shift of right, pi over 4. And now I get to put that all into an equation. So y equals, it is, if I start here, it's not reflected, so I'm just going to call it 3. And then sine. I like lots of parentheses in my function, so I'm going to open a parenthesis. Next, I'm going to write down the b value of 2. I'm going to leave it in factored form, so the phase shift is going to be factored out of it. It doesn't really say whether you to use x or theta, so I'm fancy, so I'm going to use theta. And then if we discuss that it shifted right pi over 4, what does that look like in a shift? Theta minus pi over 4, good. If you used x, it's totally fine. And then you do have a vertical shift, a midline off of 0, it's now shifted down 1. I would say, from my recollection of how you guys did on this question last time we tested it, quite a few of you, when you had an issue, it happened right here. You weren't sure how to find b. So that does require a little memory on your part, okay? You do have to have that formula in your brain, or at least the concept of what b means. Oh, there's more. Good news. I feel like we all need to practice this. So let's take a look at, again, they want a sine equation. Well, that's really hard to read, guys. Is this the origin? Yeah. So your max here is at 60, your minimum's at negative 20. So if I found the midpoint here, that would be at 20, wouldn't it? Because 60 plus negative 20 cut in half. And that looks like a good visualization. Now these blocks are counting by 20, so keep that in mind. What's the amplitude? From 20 to 60 is 40. Very good. And I like to double check my amplitudes. Like, I'll look from the middle to the top and the middle to the bottom to make sure I didn't misplace my midline. Because that's something I do. Now they did clearly identify some ordered pairs here, at least with like red points. So a normal person would think it starts and stops here, which for the period we can totally do that. It starts and stops from 0 to 3. Okay, we have a weird period length, which means we're going to have a weird b value. How do you find b? You take 2 pi and you divide it by the period. Well, there you go. That's b. That vertical shift of up 20. And then phase shift. You are going to have to call this a phase shift of some sort. So it is up to you guys where you... Oh boy, this is going to get weird. Hey, let's get fancy. Let's start here. Because it said I have to have a sine function, so I have to start on one of the midline points. Anyone figure out where this is? So this is 3, and it has to be quartered. So period divided by 4 would just be 3/4. So every one of these quarter points is a 3/4. So like this is 3/4, 6/4. I can't count. 9/4, 12/4. Yeah. Okay, let's blow that block up for a minute. Here's 0. Here's 3. That's the full length of the period, right? And if I was asking you to quarter up that period, you would take the period and you'd divide it by 4. So 3/4. So the first quarter point that you'd have to make a mark after 0 would be at 3/4, and then 6/4, and then 9/4, and then supposedly this is 12/4. Now, first of all, can we agree that 12/4 is indeed 3? Yes. A normal person wouldn't call this 6/4. What would a normal person call that? 3/2. Now, nothing's labeled. Yes, ma'am. Oh. 1, 2, that's a lie. I just ruined it. It's not! You found a mistake on the key. You win! Well, if... okay. This is 0, right? I'm not screwing that part up. This is 3. And in between here, you'd have to have 4 quarter points. Well, like this is the 4th quarter point. So if you called this 1, this would be 2, this would be 3, and this would be 4. But it's not. But this is 3 right here, and you just said it was 4. So it's me. I'm the problem. It's my mistake. So let me fix that on the key, okay? I should give you a prize. Every mistake you find, you get 1 piece of candy.
What if we did that all year?
You have diabetes. Alright, so apparently that's whoopsies on the key. So this guy right here, we just decided was 3/4 to the right. But because I'm shifting it right 3/4, what else can you tell me if this is my starting point? It's reflected. So if that's your choosing point to start at, that's fine, but keep that in mind. So that's why these are so fun to grade. Throw a negative in front to reflect it. Negative 40. Sine. Where are we at here? B value, 2 pi over 3. Phase shift of right 3/4. I'll use x this time. I'm feeling less fancy. X minus 3/4. Close the sine function, and then an up 20 shift. Now, the reason these are so fun to grade is because maybe that's not where you started your sine function, and you started somewhere else. I think we were trying to be nice to ourselves on the test, and we made it like painfully obvious where you should start it. And if you choose to go rogue on me, then I'll figure it out. But like, There's really just one good place to start the function. Go there. Got it? Sorry about the mistake on the key. It won't be my last. All right, keep going. This is where you will need to use your calculator, so make sure you're in radian mode. But first, we need to do some sketching to figure out what's going on. Oh, it's another Ferris wheel. Okay, so our Ferris wheel. He starts the watch when he is at his highest point, which is 22 feet in the air. So I'm going to call this 22. Now the picture is really just helping you guys kind of lead in and fill in all these parts. The picture doesn't have to be like in great detail, but the better your picture, the easier it is for you to develop the rest of it. The diameter is 14 feet. So from top to bottom should be a total distance of 14 feet. Where's the bottom? 8. Okay, cool. Now I'm just kind of thinking ahead here, guys. I should be able to find the middle pretty quick, which also tells me I should be able to find the amplitude pretty quick. Actually, I already know the amplitude if I think about it, but whatever. Find the middle here. 22 plus 8, 30 divided by 2 is 15. And this is where I double check my math because the amplitude should be a 7 because it should be half the diameter. So up 7 and down 7 makes visual sense on my picture. Cool, cool. So amplitude is 7. Haven't even read anything about period yet. Let's keep going. 1 revolution every 40 seconds. What is this? Yeah, if they tell you how long it takes for 1 revolution, that's the definition of period. So if I go to find the period, well, it's that. It's 40. Justify your amplitude and period. Okay, the best way to answer this is to use the context clues of the problem. Your amplitude of a wheel question is the radius of the wheel. So that would be like the clearest explanation. I know some of you go very like visual and you go, well, on my graph of mystery, I have a midline of 8, or 15 rather. And that's fine too. If you want to explain a different way, that's fine. But on a wheel question, the amplitude is always the radius of your wheel because the diameter is the full range. And then the period is the length of time it takes for a cycle to complete, which is flat out what they told you. So that's the period. The cosine equation. All right. I think we're ready to do this, except there's one thing we haven't found yet, and that would be the b value. So remember, you take 2 pi and you divide it by the period. Of course, your teachers want simplification here. So call that pi over 20. And then he starts the watch when he's up here at the top. The only thing I might add to this picture, just to show my teacher I totally know what I'm doing, is this. Because that's how we indicate period length on a graph. That's how I do, at least. I don't know what you guys do. But. So talk to me about, are you comfortable with me calling this a cosine? Because it told me to call it a cosine. Has it been reflected? Nah. Sometimes they're reflected, so be careful. Amplitude is a 7 times the cosine. The b value goes into the formula next. There's no phase shift since you're starting at the top. They want you to use t for your variable on this guy. And then plus your vertical shift, this midline is now at a 15. Now the fun part comes up. I need you to go to your calculator. It is up to you whether you use your graph, your table, or just blankly plug it in. For the sake of time, like if you were running out of time or just felt like you were done, check your mode. What mode are you in? Radian. I might just do this in the home screen since this is the only question they asked me on this one. They don't say any other predictions, but it's up to you. If you're concerned that you graphed it wrong, maybe you want to go look at the graph. If you have time for that, cool. I think you will on day 1 as long as you're not like hemming and hawing over a bunch of problems. Maybe like come back to that question if you're stuck. But if you plug in t equals 11 in radian mode, you should get an answer, and someone tell me what the answer is. What is it? 13.9. Apparently at some point in history I had a typo on that too. So label on that should be feet. I know at some point I did have a typo. I scribbled it out, I see. Fancy. So I need to fix that 1 though, huh? Number 11. Okay, I'll fix that. Yeah, I'll fix it later. Okay. Are we there yet? Almost. Almost there. Whew. Okay, so You do need to have knowledge about the inverse trig unit circle. This part you will not have. You remember that color-coded one where we put the markers on it? So this guy, remind me, you'll have a unit circle. And then there's something at the bottom. Yeah, this part. So that will be on there. So if that's like makes it all clear for you, then cool. Hopefully you guys are a little visual and you can remind me who's defined from here to here. Yeah, arctan and arcsine. And then arc cosine is defined here to here. So, and yes, that is kind of sort of explained here if you look closely. This is what they want you to do. Direct evaluation, so you got to be careful about the inverse unit circle. Where is your sine function when it's defined? When is your sine function negative square root of 2 over 2? And give me the proper name for that. So remember, arcsine is only defined quadrants 4 and 1, so you need to give me this guy down here and give me the right name. Because it's not 7 pi over 4. What is it? Negative pi over 4. Very good. And then arc cosine being negative 1/2. Well, it's, let's see, it'll be this guy over here. What's his name? Oh yeah, I kind of misjudged it. It's this guy up here, huh? 2 pi over 3. Like I said, it's totally up there. So you do have a traditional unit circle. Cosine's not the one I'm worried about, though. Alright, then there's one of these composition doohickeys. Love these. Start on the inside. It does say to sketch. That's kind of me leading you through the question. So I'm going to sketch it. And it does say arctan of negative whatever. So what quadrant are we in if we have an arctan that has a negative ratio? Because arctan is only here. So it's down here. And I'm probably not going to graph it anywhere close to scale, but what's new? So the tangent ratio is negative 15 over 8. So if you called this a 15 and this an 8, like you have to for tangent ratio, which one gets the negative sign? The vertical leg. Very good. Little Pythagorean triple here, or else you can do Pythagorean theorem. Isn't that a 17? And then they want, keep going out of the question now, it says, now find the sine of that ratio. So this is not an inverse question. This is just set up the sine ratio. So that would be negative 15 over 17. And again, this is one of those, what quadrant am I in? Do I have the proper sign for a sine in the fourth quadrant? Yes, I do. And that is the end of day 1. How you feeling? Like you're going to win, right? What I'm going to do is after, I'll grade it right away. I'm going to enter it as a homework assignment just so you can see your score. But it's not going to affect your overall grade until we get all of your parts of your final in. For seniors, that'll be Thursday. For everybody else, your full final won't be done until finals day. So I'm only doing that because I don't want you to be misled. Like if you ace tomorrow's test, and then you're like, oh, cool, I have the grade I want. I'm not going to study anymore. Well, that's assuming that you continue acing all the rest of the parts of the test along with it. So I don't want to mislead anyone. Does that make sense? Okay. All right. Who's gone tomorrow? Any AP tests tomorrow that are affecting anybody? Not tomorrow. All right. Good luck.